What's up guys, welcome back to the channel. Now on this video we'll be deriving from using the standard uh, derivative to derive this function here guys. So this is part 4 of this playlist where we derive from the standard derivatives. So I've made videos on these derivatives so you can watch them. At the end of this video there's a playlist that's going to appear. Click that and see part 1 till this part here, which is going to be part 4. Now if you are new to this uh, channel, I already made videos on trigonometry, limits, and also deriving from the first principle. You can go to the playlist section and select this playlist and watch those videos. Now if you are returning from this channel, you can pause this and try to solve this and then watch it and see if you're gonna get the same answer as the one that you're gonna get here on the video. Okay, let's start. Remember guys, when we differentiate using the standard derivative, we need to make sure that we don't have the numerator which has x there. But now as you can see here, we have we have 3 terms that have surds them. We need to change the surds to exponent, and also we need to take the exponent, the x from the numerator to denominator. So first of all, we need to simplify this. So first of all, let's start and simplify. So we have y, which is gonna be, now remember we need to take the x on the numerator to the denominator, from the denominator to the numerator. So if we take this x, we only take this x because that's what we will be differentiating. So we have x squared on the denominator. If you take it to the numerator, it's going to be x minus to the power of minus 2. And then we're going to be left with 2 on the denominator. And then we need to change this to exponent form. Remember, when you have a root like that or a square root like that, it's the same as x to the power of half. We all know that square root, when you change it to exponent, is x to the power of half plus. Now let's look at this one here. This one is 1 over 2. Remember, this 2 is not part of the root here. So what is the root there? This is the square root, but this is the power of half, so it's gonna be 5 over 2. I hope you guys know how to do this. Remember, the root is the 1 is going to be the denominator on this exponent, and then the 5 is going to be the numerator, which is the power. So I hope you know how to do this. And then we have to change this one as well. Oh, we don't change it here. We don't change it. As you can see, this cube root is only for 3, so we leave it like that. So this was just a way to trick us guys to see if we are vigilant enough, because this x here to the power of 3 is not part of the cube root there, so we have to be very careful. Then we write a 6a. Now we need to take this x to the power of half from the denominator to the numerator, and also we need to take this x to the power of 5 over 2 to the numerator. So again, do not differentiate until all the terms they have x on the numerator there. Alright, so the first term we already done that, so we just rewrite it. And the second term, we have to take this x to the power of half to the numerator, so it's gonna be minus 1 over 2. Remember guys, when you take the base from the numerator to the from the denominator to the numerator, the exponent is gonna be positive. And then we have plus we're gonna take this x to the power of 5 over 2 to the numerator, so it's gonna be negative 5 over 2 over 2. Remember this 2 here. I repeat, do not take this 2 to the numerator. We are only differentiating x, so we only take this x to the numerator. These guys do not take that 2. And again, let me go to the first term. This 2 only affects the x, the power of 2 there. It doesn't affect the 2 in there, guys. Please do not make those mistakes. And then this one here, this term here, we just write it as it is because it's okay so far. So we have 3 here, and we have x to the power of 3 minus 6a. Now this is now fine. We can start differentiating now. So we can say dy dx. Okay, before we start, there is a formula that we must use. This is the formula that we use. It goes like this: y is equal to x to the power of n, and then when we say dy dx, when we differentiate here, it's supposed to give us multiply by the exponent, which is n there, and then it's the base, then n minus 1. So always the exponent is minus by 1, and then we multiply by the exponent there. This here, guys, is a formula that you use to differentiate when you use the standard derivative. Okay, this is standard derivatives, so this is what you're supposed to use. If they say derive using a standard derivative, this is what you should do. Or if they say find dy dx, if they say for the first principle, there is a video for that. You must go and check it on the playlist. And then I made a video explaining this formula. Go and watch this video there. I explain how to use this formula and the application there on that video. Go and watch it and come back and finish this one. Alright, so let's continue. So let's look at the dy. Let's look at the first term. So our n here is -2, so meaning you must multiply by -2, right? And then we have x to the power of -2 minus 1. All this is divided by 2. There we go. And then we say minus. Now do not forget that we have the n here. Our n here is gonna be -1 over 2, right? And then multiply by x to the power of -half minus half. All right, we just deriving here, guys. We just deriving. So let's go to that term, and then we have plus there, and then remember our n here is -5 over 2, so we can say minus 5 over 2, and then we can say from the bracket, and then we say x to the power of -5 over 2 minus 1, all this divided by, let's not forget this 2 here, divided by that 2. So this is a multiplication. Remember, this is n. Now we come to this one. Well, this one is not much of a problem. We just multiply by n, which is going to be 3. And then let's not forget that our constant is going to be √3 and 3. Oh, not x and 3, guys. 3 and 3. And then we have x, and then we have 3 minus 1. Now this one here, remember, we don't have x. Our derivative is, we are deriving in respect to x. So this term here, we have 6a, there's no x here. I would say put 0. I did explain this on other videos, the previous 3 videos on this playlist. I did explain how this 0 came about. This time around, I'm just gonna skip it. Go and watch those videos. At the end of this video, they'll display a playlist. Go click on that playlist and watch one of these videos, and you'll see how this 0 came about. But if you don't see any x here, if we're differentiating with respect to x, this usually is gonna give us 0. That's all I can tell you. All right, so let's continue dy and then over dx. So now look, this is -2 divided by 2. This is gonna give us -1 multiplied by x. Now -2 minus 1, this is gonna give us -3 to the power of -3. Now if you multiply negative with -half, this is gonna give us +half. But then on the at the top here, what do we have here? We have half minus half minus 1. This is gonna give us minus it's gonna give us minus, let's do the x, it's gonna give us minus 1.5, which is gonna be 3/2. Yeah, and then we know that this 2 here is gonna be down there. There we go. And then this one here we multiply. This is a multiplication, by the way, guys. So if we multiply, let me double check here. Yes, if we multiply here, this is gonna be negative. So if you say minus 5 multiplied by x, let me just do the 5 on the numerator. So as you can see, we have 2.5 minus 1, negative 2.5 minus 1. This is gonna give us 6.5. So what when it's gonna give us 3.5. So what is 3.5? It's actually 7/2. So this is gonna give us negative 7/2. We can double check it, guys, using our calculators. We don't want to get the wrong answers, but I strongly believe that that is the one there, guys. That is the one there. So let's double check before we make mistakes, but I'm quite sure it is the one there. Yes, it is 7.5. Alright, guys, I know it is wasted time, but I needed to make sure checking my work that I did before this video. So let's continue. So we say plus. Now this one is quite easy. It's gonna be just 3, and then we have cube root, then we have 3 inside there, and then we have, now what is 3 minus 2? 1 is gonna be 2, and then the rest, that one is gonna give us 0. Now remember, you need to leave your answer in surd form or positive exponent as well. So this is not an ideal. You don't leave it like this, you might lose marks if you're writing the test. So rather leave it in a positive exponent and insert. So this one here, as you can see, we have -1. So if we take this x to the power of -3 to the numerator, to the denominator one, this is gonna be x to the power of 3, right? So let's look at the second term. So we have plus here, we have plus there. If we decide to take that x to the power of -3/2 to the numerator, we're gonna be left with 1 here to the denominator, and then we have 2 here. So we're gonna have x to the power of 3/2. Remember, guys, whenever you take the base to the denominator from the numerator, the exponent changes the sign. So we have a negative here, so we're gonna be left with 5 here, and then we just take this x to the numerator, to the denominator, I mean to say. Something is not right there. Oh, guys, I forgot to multiply these 2 here. So if I multiply these 2, we're gonna have 4. Yeah, I was busy worried about this -7/2. We're gonna have 4, but it's still fine. So we're gonna have 4, and then we have x to the power of +7/2. There we go. And then this here plus this is gonna give us well, this is gonna be like that. There's nothing to it. It's actually simple like that. So unfortunately it looks weird, but it is actually like that. All right, so let's find out. So if they say leave your answer in positive exponents, this is what they mean. But when they say in surd form, you have to change these ones with the fraction exponents to surd form. So this one here is fine. You're gonna have x to the power of 3, -1/x to the power of 3. There's nothing you can do there. But this one here, the second term, we're gonna have 1/2 we need to change this. So if we change this, it's gonna be x to the power, the square root x to the power of 3. Remember, this is 2 meaning squared, and that 3 means the power of 3. And then we say minus, and then we're gonna have 5. Let's not forget we have 4 here. Okay, and then here we're gonna have square root, and then we're gonna have x to the power of 7 plus 3, and then we have root 3, and then 3, and then we're gonna have x to the power of 2. When you look at this, this is our final answer. It looks very different, but trust you me guys, it's really supposed to be like that. Now some of you might like to continue, but I don't think we should continue here guys. I think it's okay the way it is. I think is leave it like this, don't continue guys. But if you want to continue, this is gonna take longer, but let's just continue, it's fine. You can say y dy over dx. Alright, this one you write it like that, and that one is going to be x to the power of 3, and then you say plus. Now this here guys, this here you can say 2, then inside there root you can say x squared multiplied by x, right? And then you say minus. Remember, if the bases are the same and they are multiplying, the exponent you're gonna add. So you do the same thing here. You can say 4, and then on the square root you're gonna have x to the power of 6 multiplied by x, right? Alright, so this one here you just leave it as it is. There's nothing you can do here. This one is already simplified, so it's gonna be just like that. Make sure that this x squared is not part of the, not under the square root there, because it's easy to get confused if you do that. Alright, so when we do this, we continue now and we write like that. Alright, I wasn't planning to continue, but I think it's very important. So this is gonna be 3. So as you know, we have plus 1 in the numerator, but let's look at this. We have 2. So what is this? Remember, this x squared is under the square root. So what is the square root of x squared? So it's gonna be x. Okay, and then we're gonna be left with x under the square root. Okay, and then we're gonna have 5 over 4, and then look at this. We have 6 to the power of we have x to the power of 6 multiplied by x. What is the square root of x to the power of 6? It's x cubed, and then we're gonna be left with root x, and then plus. So this is what you're going to have. We're gonna have plus 3 cube root 3, and then 3, and then you have x squared. So finally this is your final answer. But I think I've done something similar to this. You can leave your answer here guys. I don't think they'll punish you for that, but you can continue and also leave it here if you still have time, or if you want to do everything, simplify everything until it is at the simplest form. Guys, if it so happen that you didn't understand this question, do not forget to comment and ask on the comment section. If it so happen that you understood and they kind of help you, do not forget to like the video, subscribe to the channel for more videos like this, and also don't forget to share these videos to your friends who are doing the same thing. Guys, if you want to watch these videos in a sequence form, because there are certain things that I use from previous videos, you can watch the playlist that's gonna appear at the end of this video. Thank you very much guys for watching. Till next time, cheers.